Welcome to EDU World Space.
Okay. In this problem, we have light being emitted from underwater, which comes up and hits the surface of the water, which of course is an interface between air and water. And then we are asked to we are ultimately trying to figure out the angle that and ultimately the distance that the light must travel from its original point in order to internally refract it back into the water and not actually travel out. So, as in all cases of total internal refraction, the the refracted angle has to be 90 degrees. And we know the indices of refraction for air, which is just 1, and for water is about 1.33. So with all that info, we just really need to apply Snell's law, which states that n air sine of the incident angle is equal to n water, that's water. Sorry, n water is equal to n air sine theta 2. So the product of the index of refraction and the sine of the angle is equal for both media, as in all cases of refraction. So at this point, if we're solving for theta 1, which is the angle, we can find it by a little bit of algebra. It's theta 1 is equal to inverse sine of n air over n water, sine of 90 degrees, and this will become 1. So really, we're just calculating inverse sine of 1 over 1.33, which comes out to be about 48.75 degrees. So if that is the case, we can easily, by just doing a bit of trig, using this picture, we have a right triangle here. We know the height of the water, by the way, something I need to include, is 72 centimeters, which we have, h. Let's get one more page. To find r, we just apply a little bit of trig. R is equal to h tan theta 1, where we know h and we know theta 1. So we have everything we need, 72 centimeters multiplied by tan of the angle we just found for total internal refraction, 48.75 degrees, which gives us 82.1 centimeters. And that's it. That's the distance horizontally that the light would need to travel at a minimum in order to deflect from the surface. So just to recap, we applied the definition of a critical angle, which is the case where refraction is at 90 degrees relative to the horizontal. And we used some other information about the media and the height, the depth of the water, and Snell's law to find the answer. And that's it.